My name is Muskan, a computer science graduate student, and the team includes Tanish, Maxwell, and Joel Martin. And the project lead for this project is Rakesh Shah. So the agenda for today's presentation is, first, I will go through the brief introduction of the project, the objectives, and then the interns will present to explain the data sources used, the graphs or the metrics they have worked on. Basically, they will give you a walkthrough of different pages of the dashboards they have created in Tableau. Also, just to give you a background, this project is a continuation of the work already being done by some data science students. Okay, so initially, the reports were built using PHP as non-customizable PDF format. The visualizations were pre-generated, and so there was a minimal interaction based on the requirement. So there was a need to develop a platform to make it more interactive in terms of multiple functionalities. So main objectives for the project were, first, to create two commodity reports, basically eggs and beef. Then data discovery to find new data sources, then explore new and interesting infographic techniques. Then streamline all reports with better filters, as in if you can choose any state or year and see the graph. Then use tools like R or Python for data manipulation. So one of the reason to use these tools is, so basically you can use the same code later for future data sets also. And so basically the EggMark commodity reports can be used as a preliminary research in order to determine current market trends. So on the right, you can see the outcomes of the project. First, so as I mentioned, these reports give you very good KPIs and metrics. So basically, just for an example, so we couldn't get the data for beef, the production for beef. So we used, so the closest approximate, as in the number of kettles or the production of those kettles as our metric. Then we show like average expenditure or nearby food hubs. And these reports have better functionality in terms of search and filtering. And lastly, it can be downloaded as PDF. Now, can you go to the next slide? Yeah. So these are some of the data sources we have used for this project. EggMark, then USDA local food directories and agricultural marketing service, then National Oceanic and Atmospheric Administration to get the weather data, every consumer spending and demographics data for the population and see the expense graphs, and then lastly the data Excel journey. Now I would like Tanish to present his work.
Hi, I'm Tanish. So we'll start with the egg commodity report. It includes 5 dashboards. We'll go through this one by one in more detail. So the dashboards are the cover page, market and harvest trends, market consumption profile, and demographic profile, part 1 and part 2. So in the next slide, so here you can see the cover page on the right with 3 contents about overview, production, and resources. So next in the overview, so first of all, we'll see why eggs are important. So one large boiled egg has 78 calories. So the calories differ by size and how it is prepared, like scrambled, boiled, fried, etc. So it is a highly nutritious food, as they are loaded with both micro and macronutrients. So micronutrients are nutrients your body needs in large amounts, like protein, fats, and carbohydrates. And micronutrients are vitamins and minerals. So the egg has a perfect balance in its nutrients. So along with its high digestibility and affordable price, eggs can serve as basic food for humans. And in the eggs overview section of the cover page, I have mentioned 2 types of eggs that are produced: table eggs and hatching eggs. So the table eggs are for human consumption, and hatching eggs are hatched to provide replacement birds. So it also has an egg production comparison between 2020 and 2021. So the total and the table egg production are down 1 and 2% respectively, but the hatching production is up 3%. So, and also you can see the top 5 egg producing state that are mentioned in this report. So, okay, uh, so for the resources and the heat map, the data is collected from the USDA NAS service. So the data is collected from stats of the USDA NAS. It is basically a web location that allows data to be queried. For example, you can filter the data by commodity and geographical levels like national, state, and county. For like both census and survey data are used for this report. So from census program, I have used the data related to production, like production in dozens, production change over years, and production by categories. And the price and frozen stock as well. From survey, I've used the organic sales data. So no county level data is available because county level production data. So we don't think that is available anywhere, as there are few egg producers. So we have to rely on national and state level data for this report. So next. So the market and harvest trends. So on the right, you can see the screenshot of the market and harvest trends dashboard. So this dashboard has egg production, sales, price, and frozen stocks related graphs. So the whole dashboard can be filtered by states and years, like which updates production and sales related items. It also updates the titles of these items by the filtered year and state. You can see the titles of the two heat maps, say 2019 all production in dozen and 2019 all organic sales. So it is showing all production as the dashboard is not filtered by state. And I have also used dozens as the unit to measure production, as it is commonly used a metric for X. The production data is available from 2012 to 2022. And for the sales, I've used the organic sales, as regular sales data is not available at the state level for like eggs in particular, because we have the sales data for like say chicken and eggs or eggs and poultry, like combined data. So I have used the organic sales in this, and the sales are measured in dollars. And above these heat maps, you can see the boxes with total production, frozen stock, and organic sales, which are updated by year as well. So you can easily compare a state's production by total production for that year. And in the next slide, so I observed the Iowa production dropped 22.9% in 2015. So after like researching about that, I came to know that it is due to the outbreak of avian influenza, something like H5N2, so which occurred in chickens and turkeys, mainly in the Midwest. So it wiped out like 12% of the country's egg laying hens. So you can see the effect of this on the national production, as it was dropped by 3%, like 3.5%, and the prices are also up by 36%. So in the next slide, so here we are showing the organic sales data. So so this data is from the census of organics. So you can see the Pennsylvania records the highest sales with worth $104 million, followed by North Carolina and Missouri. Next. So in the market and harvest trends dashboard, I have these two graphs, which are like egg price received in dollar per dozen and frozen stock. These two graphs doesn't update with state or year filter because they use US total metrics. So in the eggs price received in dollars per dozen, you can see the price and percentage difference compared to the previous year. So as in 2015, the price increased to 36%. So, and in the frozen stock, it is divided into like 4 categories, like unclassified, whole or mixed, white and yolks. And you can see the percentage of the frozen stocks to the total frozen stock as well.
Hi, my name is Maxwell Skinner. I am a sophomore data science major at Iowa State. For this project, I was in charge of making the beef commodity report, as well as one of the agricultural demographics pages. So for the beef commodity report, it includes a cover page, market harvest trends, market consumption profile, and a demographic profile. What you'll see for both commodity reports we made, you will find a very similar market consumption profile as well as a demographic profile page as well for both the egg and beef commodity reports. So data sources I use specifically for the beef commodity report, the National Oceanic and Atmospheric Administration for state historical weather data, the USDA local food directories for the demographics page that included locations of farmers markets, foods hubs, and on-farm markets. And then I also used USDA quick stats, which was a great way to query census and survey data. For the cover page, it contains primarily USDA census and survey data. It gives an overview of the commodity and resources provided on the AgMark page as well. So it includes like the website, the food maker website link as well, and USDA AMS. The map of area producers, just to clarify, that is a map of the production that you'll see on the market and harvest trends as well. So for market and harvest trends, for the beef commodity report, this includes national cattle statistics and cattle prices received and beef frozen storage. For cattle statistics on the national level, we have cattle production by state in pounds, cattle sales by state in pounds, and beef production nationally. Just for some context about, again, to reiterate a part of why this dashboard looks the way it does, the census data doesn't have a lot of detailed reports for beef commodity specifically. So when to find things like sales of beef and the production of beef, we infer that from cattle production and cattle sales. As well as the price of beef, we infer that from the price of cattle. So for national cattle statistics, we have production, sales, and a national production line chart. The first two is just a general heat map by state, where you'll see states like Nebraska, Kansas, and Texas leading in production and sales. So for cattle prices, for the price of it, it's dollar divided by CWT, and that in general is a measurement of 100 pounds of live weight or live weight equivalent cattle. So the measure is the dollar amount of what 100 pounds of cattle is worth. So the orange bar chart represents the price, and the blue line chart just represents a percent of change from year over year. For beef frozen storage, this is just a national bar chart that shows the frozen storage of that commodity over from 2010 to 2022. And this combines both boneless frozen storage and bone-in metrics. And in general, it's a good measure of how beef is produced, how much beef is produced, and how much of that is being consumed or sold. So on to the demographic profile. So for the demographic profile, this is just, we have two parts of this, and part one is general population statistics and breakdowns by state. That doesn't pertain a lot to agriculture. So for the first page, you'll see population trend, and we can do that by state. So from 2010 to 2021, as well as a bar chart that has the year-over-year percentage change, a population distribution by race and age, household income and unemployment rate, and top industries by population. So for the demographic profile, this is the agricultural demographic profile, and it includes state export agricultural percentages, and it divides, the middle chart basically divides each commodity that a state exports into percentages. And the top two charts we see is the monthly precipitation of states by month and geographic location. So the source we used was the NOAA, and that gives raw weather station data of how much that weather station measured in that specific region. So we use that data and we sum it all by state, as we see in the top right-hand corner, that we can find what months on average receive the highest levels of precipitation. And on the left-hand corner, we can see by month what parts of a state have the most levels of participation, either by a year basis or by a month basis as well. And then on the bottom chart, you will see a map of national local food market locations. And this is a map of every single local farmers market, on-farm market, and food hub. And you can zoom in on the map and see how many there are by state. Just a disclaimer for this specific data set, this is not a definitive total of every single local food market location, because we got this data from the USDA, from a voluntary survey that local food markets can put their information on, like things like their address, the name of the farmer's market, and stuff like that. So this is not a definitive list, but this is a very good idea of, like, by state where your local farmer's market would be. Just to reiterate, for one of the graphs, for state agricultural percentages, this can be filtered by state. So each individual state, you can see how much that state is exporting in certain commodities. So for example, what we have it set up now for the agricultural profile, you'll see like what it looks like in Iowa. So for Iowa, you'll see like almost 34% was soybeans, 26% pork, corn was 16%. And we have this breakdown by state, and we also have this nationally as well. So for monthly precipitation of states by month, again, these individual points are just weather stations, and that includes the address of that weather station as well as the city it's in. And we can have this breakdown by month as well. So yeah, just a visual example of what that national local food market location is going to look like. You'll have the category of what that local food market looks like, the address of that market, the listing name, and then just for graphing purposes, we also put the latitude and longitude of that listing. All right, and I think Joel's going to take over for the market consumption profile.
Hi, everyone. I'm Joel Martin. I'll be walking us through the market consumption profile, like Maxwell just said. You can see an example of the egg one on the right. There's also one that's very similar for beef as well. We'll be going through 3 different sections. The first section is data sources. The primary data source used in this page's report was Esri consumer spending data. Some secondary sources used were USDA Agricultural Marketing Service, CDC State Indicator Report, and Data Axle Genie. We'll also be looking at data transformation and graphs. Next slide, please. So again, these are just breaking down the data sources in more detail. US consumer spending data is based on the latest consumer expenditure surveys from the Bureau of Labor Statistics. The data is for 2000, 2010, 2021, and there is predictions in there for 2026. It contains hundreds of details about products and services. If you think about like a department store, like Walmart or Target, any department in there, there's most likely a category in this data set for products in that department. So there's a lot of things in there. There's also some financial information in there as well. We focused primarily on the egg and beef expenditure, as well as food expenditures at and away from home. The secondary data sources used were, as I mentioned, the USDA Agriculture Marketing Service. The Agriculture Marketing Service administers programs that create domestic and international marketing opportunities for U.S. producers of food, fiber, and crops. This data was used to find the number of community-supported agricultures, CSAs, and farmers markets. Also used was the CDC State Indicator Report. This was used to find the number of food hubs, and a food hub is a centrally located facility with a business management structure facilitating the aggregation, storage, processing, distribution, and/or marketing of locally and regionally produced food products. Also used was Data Excel Genie, which was a tool used to access business and consumer leads, and this was used to find the number of grocery stores and restaurants for a given state. Next, this is the data transformation that was done. For the Esri, the data was in a wide format, as you can see in the top right image. Each column was a category along with the year for that category. To make this easier to use in Tableau, it was converted into a long format, which is the bottom right image. And a year column was made for year, and then the category names were given a category column as well. And we also changed state names to state abbreviations, to full names for better readability. And then no extra work was needed with the secondary data sets, as these were reused from the past data science students' work. Next slide. So now we'll start going through the graphs that are in this page of the report. So this is a first graph that you can see. This graph looks at a commodities expenditure by year. The bar graph is a selected state's average expenditure for a commodity by year. In this case, we're looking at Iowa's average egg expenditure. And then the line graph is the percentage change in average expenditure for a commodity from the previous year. So in this example that we're showing here, using 2000 as a baseline, from 2000 to 2010, egg expenditures in Iowa fell 5%. From 2010 to 2021, they rose 46%. And then from 2021 to 2026, they're expected to increase by 9%. Slide. This graph compares a selected state's average commodity expenditure to the US national average for a selected year. In this example here, we can see in 2021, Iowa's average egg expenditure was almost the same as the national average. Next slide. This graph compares the 2021 percentage of food expenditures at and away from home for a selected state and how much of those food categories a commodity contributes. So in this image that we're seeing here, we can see that in 2021, Iowa's food away from home expenditures, which is the darker shaded blue color, were about 39%, and the at-home expenditures, which is a lighter shade, were about 61%. And then in the table directly below the pie chart, of those food categories of at home, egg expenditures made up 1.3% of that category. And then in food away from home, eggs made up 2% of that category. Next slide. This is just a simple table that will show a particular state's food markets and the counts of those. Next slide. And then the last graph in the report is the graph that compares a selected state's farmers markets per 100,000 people to the national average. In the graph here that we're seeing, we can see that Iowa, for every 100,000 people, they have access to about 7 farmers markets, which is close to double the national average of about 4 farmers markets.
So that concludes our presentation slides, but we will move on to the live demo. All right. So this is when you like would open the like link to the commodity reports. This is in general what it would look like on Tableau Public. So for example, you would see the beef commodities, you would see like the cover page and then market trends. It breaks down like this. With also, you could like filter in boneless, bone out for something like beef frozen storage. And then for state as well, you could filter and just select a specific state. And for example, for every single state, you can see that exact value that that state has. So for cattle sales, in Kansas, it was like $7.7 billion, or for something like cattle production, you can hover over any kind of state and see the breakdown of what that value is per state. So market consumption, demographics profile part 1 and 2, those would be seen on both the egg and beef commodity reports. So this market consumption profile, these filters can break down by a state. So for something like Colorado, you'll see it changes a little bit, or for Arizona, you could do all 50 states and filter it. You could also filter by the year as well. So 2000, 2021, and that would just be for specific for graphs that have like specific year markers and not the year over year comparisons. And yeah, so for the demographics profile, just for the population size and those kinds of metrics, those can also be filtered by state as well. As you can see, we can filter all states. So yeah, Muskan, do you have anything to say?
I think, yeah, that's it. We are open to questions now.
I have questions. I have two. My first question is about the weather station data. So if you don't mind going back to that slide. Okay, so for this one, you said you took all of the weather stations and you summed the values.
Sorry, I didn't sum the values. It's on average.
Okay,
It's on average by all states. So you'll see the metric is by feet. So it's like 0.05 feet or stuff like that. And then on average, it's the average precipitation by month. Sorry, I should have clarified that earlier.
I was just wondering because
I
I was thinking about other states, maybe like Wisconsin has fewer stations, and then that if you summed it, that would make it different. So
yes,
average would be right.
It is on average, yes.
And then my second question has to do with the Esri data for food preferences. Joel, you talked about transforming the data from wide to long. Did you do that in an R script?
Yes.
And then that the original data set, was it at the county level, tract level? Do you remember?
It was at the county level, I believe.
Yes, so the Esri data is at a county state level. Yeah.
Okay. All right. I just wanted to verify those two things, but I've noticed that this has gone a long ways from our last meeting, so I just want to let you know that I've noticed all of the hard work you guys have put in this last portion of the program. It looks really good.
Thank you, Willie.
Thank you. Oh, sorry.
I had a quick question. On one of your charts, it had some, it was about beef. It was like frozen beef commodities. And just looking at that graph in 2014, it showed a major drop. And I was just wondering if that was, I don't know, some sort of inconsistency or an issue with the data, or if you knew what might have created that big deviation from the trend.
So from the information we gathered, there was like cattle disease at the time. So just like in egg production, it was effective. It was a similar kind of situation in cattle production as well. But you will see for bone in and bone out frozen storage, there is like it is different metrics. Like you'll see for bone in storage, you'll see it's a steep decline over the past couple of years. But for something like boneless, you'll see it's like peaked in 1 year and then it's kind of leveled out. And this is the average. The all would be the combined values of both.
Thank you.
I just wanted to quick comment and commend you all on your hard work. I agree with Bailey. This is light years from where we were at our last meeting. And so I can tell you guys have really put in a lot of effort here in a short amount of time too. So thank you for that. It looks really good.
I have a question for you. You may have said this and I missed it. I apologize if that's the case, but if someone wanted to access the data that you used for this, I know that there are features on Tableau for that, but have you enabled any of the like downloadable features as well? Or
So yeah, you can download the workbook, like the package workbook, from the Tableau online link as well. So you can see there's a download icon here, like left of. Okay.
and
So
that
can
is
you,
awesome. I'm super excited. But as we're thinking about like our other partners who will be using this moving forward, I'm wondering about is this all in like a Git repository and everything? Yeah, we're all okay.
Yeah,
awesome.
all of their data sources are in our Git repository that we've been working on. So, yep.
Okay. Yeah, it looks so great. It looks really wonderful.
And then Cass, next steps for this project is we'll take the students' work and we'll publish it online with the rest of our AgMark commodity reports that we already have up. So
Okay.
yeah, that will be next steps too.
Great. I know that we have some artificial intelligence sponsors and partners in this that are really excited, and we've let them know that the data will also be available. So getting some of that piece with the GitHub will be great. It looks so good.
All right, are there any final questions? Okay, I'll go ahead and stop the recording then, and thanks everybody for joining us.
Thank you.